Hello, in this video, I am going to discuss AS Physics, February-March 2024, paper 22. But not just mere discussion that I'm going to do in this video, but also will teach you how you could score full marks in your paper 2, as well as to guide you through the keywords and how are you supposed to avoid making careless mistakes at the same time. Now, let us begin with the first question. A, Table 1.1 lists some SI or standard international quantities. Complete the table by indicating with a tick which rows are SI-based quantities. So you need to understand what are the base quantities. You are asked to memorize 6 base quantities altogether in your AS syllabus. First is definitely current is one of the base quantity. And energy is not a base quantity, force is not a base quantity, but mass is a base quantity. So if you take 2, you will gain that 1 mark. B, use the definition of power to determine its SI base unit. So what is the definition of power that you have to recall? Power is defined as work done per time taken. Work is defined as product because I have to break it down to the simpler units in order for me to rearrange it in the SI-based units. So work is defined as the product of force and distance moved in the direction of the force divided by the time. And force, if I want to remember better, I just put F equal to MA. F ma MA times the distance over time. Now, I can sub into my base units into this equation. M is mass. Mass, the standard international unit of mass is kilogram. A is acceleration. Standard international unit of acceleration is meter per second square. And distance is measured in meter per time, measured in second. So you have to work this out. We'll end up getting kilogram meter square as -3. So the SI base units of power is kg m square as -3. C. A light meter is used to measure the intensity of light in a classroom. Daylight is incident normally. Normally means 90 degrees on the sensor of the meter. The sensor has an area of 2.2 cm square. The reading on the meter is 950 watt per meter square. So calculate the power of the daylight incident on the sensor. You have to recall the equation of intensity because intensity is given. So to help you to identify which equation that you're supposed to use, I write down, oh, this is area and this is watt per meter square. Watt is the unit of power. Meter is the area. So to calculate the intensity, they have already told you this is intensity. So intensity, sometimes you do not have to remember the equation. So you just look at the unit. It has intensity must be power per area because what is measuring? What is the unit of power? And meter square is the unit of area. So our intensity is defined as power per area. I just sub in, but the area, look at the unit of intensity. It is in meter square. So you have to change your area, cm square, to meter square. Now, I is 950. I have to find the power area. So area is 2.2 cm square. How are you going to change it to meter square? I memorize the prefixes. C is one of the prefixes which carry the power of 10 to the power of -2. But this is cm square, so you have to square the c. So you get 2.2 times 10 to the power -4 meter square. And I just sub this in, 2.2 times 10 to the power -4. You do your cross multiplication after that, you will end up getting 0.209 watt or 0.21 watt as your answer for your power. The next one, question number 2, define acceleration. So acceleration is defined as rate of change of velocity. If you don't like my definition, it doesn't matter. You just put final velocity minus initial velocity per time taken. Could be accepted as well. But some students wonder whether we can put equation in our definition. I would tell you I have no problem with that. You can just write A is equal to V minus U over T, but you cannot leave your answer just like that because every symbol that you use here, you have to explain. So you have to put here which A represents acceleration, V represents final velocity, U represents initial velocity, and T represents time taken. You have to explain every single symbol that you are using here. B, an Olympic diver stands on a platform above a pool of water as shown in Fig 2.1. When the diver is on the platform, his center of gravity is a vertical height of 9 meters above the surface of the water. So it has been shown here. The diver jumps from the platform with a velocity of 5.9 meters per second at an angle of 60 degrees to the horizontal. Air resistance is negligible. That is good news. When the diver hits the surface of the water, his center of gravity is a vertical height of 1.2 meters above the surface of the water. It's given as well on the diagram, on the figure. Calculate the speed of the diver at the instant he hits the surface of the water. Now, when you look at this type of question, it says that the diver jumps going down and they talk about center of gravity. Can you see? That's a hint. That's a hint. So you can use free fall equation. What is the equation that I'm supposed to use here? I am going to use V squared equals U squared plus 2AS, right? But since this is free fall, I'm going to replace that A with G, GS. I'm supposed to find the speed, which is V squared. Initial speed. They told us that this is the initial, this is the speed. But this speed, 5.9 meters per second, is acting at a certain angle, which is 60 degrees. If I want to use the G in my equation, I need to make sure that this initial velocity must act in the direction of the gravitational acceleration. So I have to solve it in vertical direction. So I find V vertical. So all you need to do is just draw. Okay, this is what we call V vertical. How to find V vertical? Pythagorean theorem. So you use sine 60 is equal to opposite V vertical. Or I just put it U vertical. I don't want to confuse you. This is initial velocity vertical direction. So U vertical over 5.9. U vertical is equal to 5.9 sine 60 degrees. That's all. Just sub it into this equation. 5.9 sine 60, and you have to square it, plus 2, negative 9.81, and the distance is negative 9. You know why I put negative? Because the U that I resolve is acting in vertical direction. The G is acting in downwards direction. U vertical is acting in upwards direction. So since velocity, gravitational acceleration, and the displacement are all vector quantities, you have to put in negative and positive to the directions. Since I consider upwards as positive direction, G is acting in vertically downwards direction, I have to put negative. And you look at this diver is going down, so the displacement is going downwards, so it has to be in negative direction as well. That is the reason why I put negative to my answer. And when you solve it, you should be getting 14.2 meters per second as your answer. So since they want just speed, you ignore. If you get a negative value, you just ignore. So I get 14.2 meters per second. That's the answer. C, the diver in B enters the water and decelerate. This is a keyword, another hint given here. Decelerate means the speed of the diver is slowing down. First part, describe and explain the variation of the viscous drag force. Viscous drag force is just like resistance. When the diver enters the water, there will be resistance of the water acting on the diver, just like how air resistance acting on your body when you are running, right? So viscous drag force acting on the diver in the water as he moves downwards. So I would say that the variation of the viscous drag force, right? Since the diver decelerate, So what happens to the speed of diver? Since diver decelerates, speed of diver is decreasing. I would say that viscous drag force depends, just like as resistance, on speed of diver. Hence, viscous drag force acting on the diver decreases. That's the answer. D, the diver has a volume of 7.5 times 10 to the power negative 2 meter cube. The density of the water is 1 times 10 to the power 3 kilogram per meter cube. Show that the upthrust force or upthrust acting on the diver when he is entirely underwater is 740 Newton. Do you still recall the equation of the upthrust? Upthrust is the floating force, or sometimes it is called buoyant force. Upthrust force is due to the pressure difference acting on different surfaces of the diver, top surface and bottom surface. Upthrust force is equal to rho Vg. Rho represents density of the water, V represents volume of the diver, and G represents gravitational acceleration. So I just sub in the value, 1 times 10 to the power of 3. This is 7.5 times 10 to the power negative 2, and G is 9.81. And whenever a question asks you to show something, you cannot just copy the answer. You cannot just write your final answer as 740 Newton. You have to use your calculator and show the intermediate answer that you got from the calculator. So my answer, 735. It doesn't matter how many significant figures that you put here because this is not your final answer. And you round it off to 740. That's the final answer. That is how you're supposed to show. Third, at particular instant, when the diver is entirely underwater, his horizontal velocity is 0. Viscous drag force acting on him at this instant is 950 Newton vertically upwards. The diver has a mass of 78 kilograms, 780. So determine the magnitude and direction of the acceleration of the diver. If you see this type of question, magnitude and direction, whether it is a magnitude of acceleration, it is a magnitude of resultant force. Yes, exactly. You have to find the resultant force first. Then only you can determine the acceleration. Because after all, if there's an acceleration, there must be resultant force acting on the diver. So I'm going to do that. I'm going to draw it. I'm not good in drawing, so I just assume that the diver is like this. This is a leg, okay? Okay. Oh, okay. I'm not good in drawing. I'm so sorry. You just imagine that this is diver, and there is mass of the diver. Okay, but I don't want mass. Mass is a scalar quantity. I just want to tell you weight of the diver is here. 78. Weight of the diver is 78 kilogram times 9.81. W equals mg. So 765.1. It doesn't matter how many significant figures I put in for my weight because that's not my final answer, right? And they told us that there's a viscous force acting vertically upwards. So I draw viscous force, but I'm using different color here. Viscous force is 950 Newton. Okay. And another force there is acting at a particular instant. The diver is entirely underwater. But you have to understand that there must be an upthrust force acting on the diver as well, which is 740, the one that we proved just now. 740 Newton. That is the upthrust force acting on the diver. Now, I need to find resultant force. Could you see that I have two forces acting in upwards direction and one force is acting in downwards direction? Resultant force, you put negative to downwards and I am going to put positive to upwards direction. So 950 Newton plus 740 Newton plus negative 765.18 Newton. So my answer should be, give me a while, plus 740 minus 765.18. That gives me 924.82. 924.82. And hey, resultant force, remember, is equal to MA. 924.82 is equal to mass of the diver 78 times acceleration. So just make acceleration as a subject. A is equal to 924.82 divide 78. My acceleration is 11.9 meter per second square, or you can round it off to 12 meter per second square. So 11.9 is my answer, and the direction, because the upward force is larger than the downward force, therefore the direction is upwards. That. Now the next one, a thin metal wire X of diameter 1.2 times 10 to the power negative 3 meter is used to suspend a model planet as shown in Fig 3.1. Variation of strain with strain of stress for wire X is shown in Fig 3.2. The strain in X is 5.4 times 10 to the power negative 3. Use Fig 3.2. Whenever they ask you to use a figure, you have to use it. So you have to check from the figure. Okay, so the strain is 5.4. 5.42468 5.4 is exactly here. 5.4 times 10 to the power negative 3. All you need to do is just to check the answer. This is 5.4. I look at the value of my strain. So the value of my strain is here, exactly here. And this point over here is 0.72. So just use the equation to calculate the force. I got my stress, which is defined as force over area. Now, the stress that I got from Fig 3.2 is 0.72. But hey, what kind of careless mistake that you could make here? Look at the unit. It is gigapascal. Giga means 10 to the power of 9. So you have to put times 10 to the power of 9 to avoid careless mistake. Remember? F, you have to find. Area, it seems like the area is not being given. No worries. Remember, they give you the diameter of metal wire. So for metal wire, you have to think as the surface of the metal wire is a circular surface area. So this is called surface area. A is equal to pi r squared. This is a little bit of math here, but the problem is in our laboratory, we do not have any apparatus that could be used to measure the radius of the wire. So all we have is a micrometer, and micrometer can be used to measure the diameter of the wire. So how am I going to relate the diameter and the radius? Radius is equal to diameter over 2. So I sub into this equation, I have d over 2, but I have to square everything because this is r squared, and my area is equal to pi d squared over 4. Sub into the equation, pi d squared over 4. That is how I make use of diameter. 0.72 times 10 to the power 9 is equal to force over pi d is 1.2 times 10 to the power of negative 3, but you have to square it divided by 4. So work it out, cross multiplication. Your force is actually equal to 814 Newton. So 814 is my answer. The second part, the elastic potential energy of X is 0.31 joules. Calculate the original length of the wire before the model planet was attached. So still remember the equation of elastic potential energy. There are two equations actually. Elastic potential energy can be calculated by using half kx squared, or elastic potential energy can be calculated by using half fx. So it depends on which equation you want to use. But since the k is not being given, spring constant, wire constant is not being given, I am going to use half fx. Elastic potential energy is given, which is 0.31. So I put half. The force is 814, and I find my extension first. My extension is equal to 0.31 times 2 divide 814. My extension is 7.62 times 10 to the power of negative 4 meter. But hey, the question asks us to find original length. Remember, how do you find original length? Okay, don't worry. They didn't give you the final length, but you could use the equation of strain. Remember the definition of strain? Strain is defined as extension over original length. That is the reason why I need extension. So strain is given, which is 5.4 times 10 to the power negative 3. Extension is 7.62 times 10 to the power negative 4. All I need to do is just to find original length. So cross multiplication of 7.62 times 10 to the power negative 4 divide 5.4 times 10 to the power negative 3. You will end up getting 0.14 meter as your original length. So 0.14 is the answer. Now the next one. Wire X is replaced by a new wire Y with the same original length. Okay, this is very important. You have to understand original length of wire Y is 0.14 meter as well. But the diameter of wire Y is the same as the diameter of wire X. But, okay, this thing is very, very tricky. Double the Young modulus of X. But wire Y also obeys Hooke's law. You have to draw on Fig 3.2 a line representing the variation of the strain or stress of Y. No worries. So we know that I put Y X means Young modulus of wire X. Young modulus of wire X, I just calculated, it is stress of X per strain of X. So stress of X, I'm using 0.72 times 10 to the power 9 over strain of X, which is 5.4 times 10 to the power of negative 3. I'm using that strain here, and then I got the value of the stress here to find my Young modulus. So my Young modulus of X is 1.33 times 10 to the power of 11 Pascal. And now they told us that the Young modulus of Y is double. So all you need to do, double 1.33 times 10 to the power of 11 Pascal. I got 2.66 times 10 to the power of 11 Pascal as the answer. Now, 2.66, right? To find we have the value of Young modulus of Y, but we do not have the value of stress and strain. No worries, no worries. I would like to draw my graph because it has to be a straight line graph. I would like to draw my graph. I would say that, let's say, the stress of wire Y at 1 meter is 1 times 10 to the power of 9. What is the strain of the wire Y? So I just find from that. So I do my, okay, homework here. So Y, Young modulus of Y is equal to 2.66 times 10 to the power of 11 Pascal. You know, Young modulus is equal to stress over strain. Let's say the stress I want to take at 1. So 2.66, just use 2.66 times 10 to the power 11 equals 1 times 10 to the power 9, and I find my strain at that point. So the strain of wire Y that I'm supposed to get is 3.76 times 10 to the power negative 3. So this is the point that I got. So all you need to do, just take out your ruler, okay, and start from origin, because if there's no stress, there's no strain. Start from origins here, and then all the way up to the point, okay, that I have plotted here. Okay, somewhere here. Okay, so all you need to do is just to draw a straight line like this. Just like that. Go back to the question. That's the line that you have to draw. Now, question number 4. A nucleus P undergoes alpha decay to form nucleus Q. A, complete the equation for this decay. Alpha, you have to understand, alpha is helium nucleus. Helium nucleus is 4,2 He or 4,2 alpha. And then all you need to do is just to balance the nuclear number and the proton number. So for nuclear number, right, 215 is equal to something plus 4. So to find this value of the nuclear number of Q, you just take 215 minus 4. That gives you 211. So 211 is the answer for this. And here, proton number of Q, you just take 84 minus 2, that gives you 82. So just sub in here, 82. Now, B part 1, state the principle of conservation of momentum. 2 marks are given. So how do you gain the 2 marks? First of all, you have to include in a closed system. Why do I even mention closed system? Because momentum is related to moving mass. You have mass and you have to move. Whenever we are moving, there are so many forces, resistive forces that could be acting on us. Like for example, I am running. So whenever I run, air resistance will be acting on me. It is not possible for me to run in vacuum, right? I need to breathe. So air resistance will be acting. If I were to consider that air resistance into my consideration, my calculation, things would be very, very messy and complicated. So principle of conservation of momentum states that I just ignore all the resistive forces. That is why you have to include closed system. That also means that you excluded, you ignore air resistance, you ignore frictional force that could be acting on the moving object. Closed system is a must, is a keyword. You have to write this in. In a closed system, okay, total momentum before, okay, you can say collision or total momentum before can be equal to, okay, or I just say total momentum before must be equal to total momentum after, or the sum of the momentum is always observed after, sorry, after. That's all. Second part, before the decay, nucleus P has a speed of 3.2 times 10 to the power 5 meter per second. After the decay, nucleus Q is stationary. Calculate the speed of alpha particle after the decay. I would say that before decay, P has a speed. I have to look at P first. You should remember the equation of momentum and U. So before the decay, only P. There's only P here. So that is why the mass of P is actually the nuclear number of P. The nuclear number of P is 215, but this is 215U, remember? Unified atomic number. And the speed of P is 3.2 times 10 to the power of 5, which is equal to after the decay. Nucleus Q is stationary, good news, but alpha, that is moving. So alpha is for U, moving with a certain speed, V. I just put it as V. Now, since both sides have U's, you just cancel the U, unified atomic number. And then you solve for V. V is equal to 1.72 times 10 to the power 7 meter per second. So 1.72 times 10 to the power 7 meter per second. That's the answer. The next one, question number 5. By reference to the direction of propagation of energy, state what is meant by transverse wave. Do you should remember the definition of transverse wave? Transverse wave, wave means vibration. So you have to include the word vibration. That's the key word. Vibration of what? Vibration of particles. Vibration of particle, what to do with it? Vibration of the particle is perpendicular. Perpendicular. Perpendicular is the keyword. You don't like the word perpendicular, you can replace it with 90 degrees. You can replace it with right angle. Yeah. Perpendicular to what? Perpendicular to the direction of propagation of energy, or perpendicular to the direction of energy transfer. B. A space telescope is designed to detect electromagnetic radiation with wavelengths in the range of 12 micrometer to 28 micrometer. State the region of the electromagnetic spectrum for this radiation. So you are asked in the syllabus to actually memorize the range of frequencies or the range of wavelength of different electromagnetic radiation. So this is the region of infrared. That's the answer. C, a detector on another space telescope detects an electromagnetic wave. The signal from the detector is transmitted to Earth and displayed on an oscilloscope as shown in Fig 5.1. Frequency of the signal displayed on the oscilloscope is equal to the frequency of the detected electromagnetic wave. Time-based setting on the oscilloscope is 5 times 10 to the power negative 15 second per cm. Calculate the wavelength of the detected electromagnetic wave. So since this is 3 marks question, definitely the calculation would not be that easy. So do you still remember the equation of wave? V equals F lambda. I'm supposed to find this lambda, but the problem is I don't have the frequency. And bear in mind, all the electromagnetic wave travels with the speed of light, which is 3 times 10 to the power 8. So we have the speed 3 times 10 to the power 8, but I don't have the frequency and I am supposed to find lambda. No worries. When oscilloscope is being given, first of all, by looking at Fig 5.1, you have to determine equilibrium position or fixed position. Fixed position is a horizontal line that we use for our calculation, which split the two peaks of the wave equally. So this is it. So this is 1, 2, 3. This is 1, 2, 3 downwards. And then after that, you find frequency is related to period, right? Period, frequency is 1 over period. Time base is given, so we can use the time base to find our period. So I start from here. One complete oscillation is from here to here. So how many cm involved? 1, 2, 3, 4, 5, 6 cm involved altogether. So period is equal to 6 cm times my time base, which is 5 times 10 to the power negative 15 second per cm. So cm and cm cancel. The period that I got is 30 times 10 to the power negative 15 seconds. Sub into the equation, you can find your frequency. 30 times 10 to the power negative 15, and my frequency is 3.33 times 10 to the power of 13 hertz. Once I got the answer, all I need to do is just to sub in. 33 times 10 to the power 13 lambda. Lambda, make lambda as a subject. Lambda is supposed to be 9.1 times 10 to the power negative 6 meter. 9.1 times 10 to the power negative 6 meter. That's all. Now, question number 6a. Coherent visible light of a single frequency is incident normally on a double slit. This produces a pattern of bright and dark interference fringes on a screen, as illustrated in Fig 6.1. There are 7 bright fringes. Explain how the pattern of bright and dark interference fringes is formed. 3 marks. Whenever you see 3 marks is given, you need to at least write 3 points. So I would say, I would talk about the bright fringe first. I would say that, okay, this is between 2 waves, right? Meeting each other at one point to give you bright or dark fringe. When waves are meeting each other in phase. In phase, that means 0 phase difference, no phase difference. No phase difference meaning to say that there's no angle difference, right? On screen, a bright fringe will be formed. That is about the bright fringes. And, okay, when waves are meeting each other out of phase, okay, by 180 degrees. It has to be 100%, 180 degrees. That means crest must meet with a trough, 100%. Yeah, crest must coincide with a trough. Then only you can see 100% dark fringe. A dark fringe will be formed. So you have to talk about out of phase, not only out of phase, but also by 180 degrees. Then only you are able to form a dark fringe, completely dark fringe. The second part, the distance between the centers of bright fringe X and bright fringe Y in the pattern is 10.2 mm. The slit spacing is 1.2 mm. Distance from the slits to the screen is 3.1 meter. Calculate the wavelength of the light incident on the slits. Now, they gave me 10.2 mm, right? So I'm using this equation actually. Lambda is equal to AX over D. Do you still remember this is the equation of interference? Lambda represents the wavelength, A represents the slit separation, X represents the fringe separation. That means from bright to the next bright fringe or dark to the next dark fringe. D represents the distance from the double slit to the screen. Now, the problem is that they give me the distance between so many bright fringes, but I want X to be distance between this and this, from one bright to the next bright. So I have altogether 1, 2, 3, 4, 5, 6 bright fringes. To find X, X is equal to 10.2 mm divided by 6, which is equal to 1.7 mm. Don't make careless mistake. It is not 10.2. X must be distance from one bright fringe to the next bright fringe, or one dark fringe to the next dark fringe. A is given as 1.2 times 10 to the power of -3. X is 1.7 times 10 to the power of -3 as well. Millimeter, you have to change to meter. And D is given as 3.1 meter. So work it out. You should be getting 6.58 times 10 to the power of -7 meter as your wavelength. 6.58 times 10 to the power of -7. The next one, the light is replaced by different visible light with a shorter wavelength. State how the new fringe separation will compare to the original fringe separation. Well, when you see this type of question, always write down the equation that you use for the calculation. So I'm going to write this now. Lambda is equal to AX over D, replaced by shorter wavelength. So wavelength decreases. A and D, same double slit that you are using, same distance between the slit and the screen. So A and D are constant. Lambda decreases, X will also decrease. So X decreases, meaning to say that the new fringe separation will be closer to each other. B, a stationary wave is formed on a stretched string AB as shown in Fig 6.2. P, Q, R are points on the string. On Fig 6.2, draw a cross X to show the position of a node. Since they have already told you stationary wave, it is advisable for you to draw the wave profile of the stationary wave so that you can see. Okay. Node will be put a cross X on the nodes. Okay, so this is my node X, or anywhere here. Well, that should be your node. The second part state the phase difference between P and Q. Now, when you talk about P and Q, right? So you know that stationary wave is being formed by two different waves that superimpose each other in the opposite direction, right? Or incident wave superimposed with the reflected wave to give you stationary wave. So if you like the wave that they drew, ignore my wave. You just look at this wave, the one that I highlighted green. Bear in mind, for stationary wave, yeah, the phase difference could be 0 phase difference or 180 degrees only, right? The points on the stationary wave can be 0 phase difference or in phase, or phase difference out of phase by 180 degrees only. How do you see? If you like the one that I highlighted, just look at that wave profile. Look at P, look at Q. They are on the same wave, right? So you know that this is what we call loop. 1 loop, 2 loop, 3 loop. So if you like the wave profile that I highlighted, you just look at this wave profile. You could see that this wave profile is being formed when the particles are vibrating upwards. All the particles between this loop are vibrating upwards. So P and Q has 0 degree phase difference. But what about P and R? P, you look at this wave profile. R, to form this wave profile, all the particles must be vibrating downwards. So P and R, the phase difference is 180 degrees. That is how you see. Now, question number 7, define electric potential difference. So electric potential difference, V, is defined as W over Q, which is work done in moving a charge from one point to another point. So the keywords are work done, moving a chart, one point to another point. This is very important. B, a cell of EMF or 1.8 volt and internal resistance R is connected in parallel with a resistor of resistance 6 ohm and a filament lamp as shown in Fig 7.1. The switch S is open, the emitter switch S is open, meaning to say that the current can only flow in this circuit without the lamp. Emitter reading is 0.25 ampere. Determine the internal resistance. If the question asks for internal resistance, always use this equation. EMF is equal to V plus IR. Or this V, by accordance to Ohm's law, V is equal to IR plus IR. So if you want to factorize it out, if you want to factorize out the I, you could. So IR plus R. EMF is given as 1.8 sub in, current is 0.25, R here given as 6 ohms. So you put 6 plus R. So work it out for your internal resistance. You should get 1.2 ohm as the answer. Now, C at time T1, switch S in Fig 7.1 is closed. Ooh, 6, ooh, so 6 switch is closed, so the current will flow in the lamp as well as in resistor. And Fig 7.2 shows the variation with time T of the emitter reading I. Right. So state whether the EMF of the cell after T1 is greater than, less than, or the same as it was before. Bear in mind, if the battery is not being changed, the EMF is always remain the same. Remain the same. It would not change. The one that is changing is potential difference. Second part, by considering the effect of the lamp on the total resistance of the circuit, explain the variation of the emitter reading shown in Fig 7.2. So I would say from 0 second to T1, the total resistance is related to 6 ohm only. So that is why total resistance is constant. But at T1, okay, at T1, current increases. Do you know why? Because at time T1, switch S is closed. When switch S is closed, 6 ohm and this lamp are in parallel. So if they are in parallel, the total resistance will decrease. The total resistance of the circuit will decrease. That is why the current increases, right? Lamp and 6 ohm are in parallel. Total resistance of what? Total resistance of circuit decreases. Hence, current increases. That is why the current is increasing. But after T1, you could see that, after the lamp is being switched on for a while, right? Due to the temperature of the filament bulb, which is increasing, right? So the overall resistance of the lamp will also increase because of the temperature of the lamp increases. That is why the resistance of the lamp will increase, which increases the overall resistance. That is why the current starts to decrease. So after T1, the temperature of lamp increases, resistance of lamp increases, hence total resistance of circuit increases, current decreases. So use a lot of increases, decreases, and then when you state the resistance, is it about resistance of the lamp only or the total resistance? So you have to state it clearly. Last question, question number 8A, state the name of the class or group of the fundamental particles that contains a neutrino. Fundamental particles, that is leptons. B, a hadron P has a charge of positive 1e, where E is an elementary charge. The hadron P is composed of a down anti-quark and only one other quark. Identify a possible flavor for these other quarks. If you want the hadron to be positive 1e, yeah, the other quark could be up quark. Or you can say charm, yeah, and state what type of hadron is P. P is called meson because it contains 3 quarks. Now, P is called, okay, meson. Nucleus Q undergoes radioactive decay to form nucleus R, emitting an anti-neutrino and another particle X, as shown in the decay equation. State the name, state what particle is represented by X. So I would say that this is anti-neutrino. So anti-neutrino, it is related to 0, -1. That is called electron or beta negative particle. And the second part, compare the nuclear number of Q and R. Nuclear number, because the nuclear number of X is 0. So basically nuclear number of Q and R is the same. Or same or equal, doesn't matter. Now compare the charges of Q and R. You see, look at R. R need to minus 1 proton, yeah, in order to become Q. That is why I would say the charge of R is greater than charge of Q. So that is the end of the discussion of our AS February-March 2024 paper 22. If you want to get the full access of the PDF solution, you could always join my Facebook group. All you need to do is just to answer 3 questions sincerely, and you could download the PDF file in my Facebook group. So see you again in my next video. Bye.